my name is Golparvar. I am Chief Technology Officer and co-founder of Reconstruct. Reconstruct is a software as a service solution for remote construction progress monitoring and inspection. And I'll be happy to address that later in my call. I also wear a second hat. I'm an associate professor of civil engineering, computer science, and technology entrepreneurship at the University of Illinois at Urbana-Champaign. So over the past 15 years of my life, I've been working on a variety of AI solutions, specifically computer vision, and more recently, natural language processing. Some of which have actually translated from our academic work into startups. Reconstruct happens to be one of them. So the company was founded 5 years ago, and from a team of 2, it's scaled to a little bit over 50 people now and thousands of projects in 4 different continents. So what I'm going to be sharing with you today is a new initiative that I formed about 18 months ago here in the United States to establish the very first institute for AI in construction, why we need to have that, and what is the right time, why today is the right time to have that. And I'm also going to give you an example of what kinds of things institutes like this can actually perform that can form a foundation for AI-driven products, and Reconstruct happens to be one of them. So I'm going to touch on how reality mapping as opposed to reality capture can be formed, and how these mapping strategies can be driven by BIM, which the good news is actually a mandate here in United Kingdom. So with that background, now I actually work in the area of AI. I don't intend to cover everything that I work on. I'm only going to make one example, but my past 15 years or so, it's primarily been at the interface of computer vision and construction management. And computer vision is sort of that branch of AI that looks into analyzing images and videos. I've always been fascinated by that because, when you think about construction folks, whether you're a foreman, whether you're a superintendent, a project manager, or maybe an executive, or maybe a designer, if there's one common medium that we can all use to communicate what work needs to be done, the basis of the design, and the interface between the two of them would be that visual data. Images speak the truth. So if I can find ways by which I can extract data from them automatically, then we can streamline many of our workflows that we see on our job sites day to day. And I can make sure that if my automation fails, I can always go back to the visual data and use that as a backup, so I can verify whether the numbers that I have from an automation perspective make sense. So I've been looking into this in the context of a range of construction monitoring use cases, and also how we can operate and manage existing facilities. And there are quite a few examples, things that I've done in the area of automated recognition of progress, things that we've done in terms of automated condition assessment of existing assets, how we can autonomously perform reality mapping, what are the techniques that we can bring augmented reality to cell phone devices so you don't need specific hardware, and also things that we can do with analyzing activities of workers from a safety, ergonomics, and productivity perspective. So in the first part of my talk, I'm primarily going to speak about why Institute of AI in Construction and why now. This is about an initiative that we started about 18 months ago, led by University of Illinois, and I happen to be the principal investigator for this project. There's 8 of us at the University of Illinois, and we also have colleagues from Carnegie Mellon University. The effort has been funded by National Science Foundation here in the US, and also Discovery Partners Institute, to put together a community that can, streamline everything that happens around AI-driven products, and how that can actually manifest itself in terms of ROI on our construction sites. But before I get into the details, I want to share with you some statistics. Last few years have been really exciting years in construction. We've seen the highest amount of value that go into construction over the past 12 years. So the value put in place has actually exceeded $1.4 trillion. Even with pandemic, because of the backlogs that we have in construction, the growth was roughly around 0.5% growth. We were expecting that to be around 3 to 4%. So of course it dropped, but we still had some growth in our construction industry. While there's tremendous amount of money that's going to construction, given the sheer volume of the work that needs to be done, we actually see quite a lot of inefficiencies that are associated with how we are executing our projects. First and foremost, there's still a significant amount of our money that goes into managing resources that we have on the job site. And when it comes to how we are coordinating and communicating what work needs to be done, there are many reports that are being published by CII, Projecting Success Group, FMI, and Forbes that are actually showing that there's a huge gap in terms of what we expect to see happen on the job site versus how the really happens in terms of the reality of the site. So if you do the math, that 35% number that I have to that 40% times that construction value, the opportunity that we have to enhance our productivity in construction industry, that almost comes close to about $200 billion. Now, some of you guys might be aware of projects that we have here in the United States. One of the major ones that I love to track on a daily basis is Inglewood Stadium. That's the largest American football stadium that we have under construction today. And that's roughly around $5 billion of work. So if you put that into the context, that means if you can address that productivity improvement, that would be 40 times Inglewood Stadium. I wish I could have done this calculation for you for Wembley Stadium. I don't have that number, but you can see the impact that we can all make if we can enhance the productivity that we have. But what does this number really mean to us? You know, that number is more at the industry level. For those of us that are engaged in construction projects on a daily basis, that means a lot of our projects, given the pressure that we see from the clients to deliver the projects fast, given the fact that we don't have mechanisms to properly coordinate the work, it impacts our bottom line. If you take a typical construction project, more than half of these projects that we perform are behind the schedule. And when we even bring in the best construction practices, lean construction, pool planning, there's still a significant amount of our projects that fall behind. And if you go beyond average commercial project, start touching on, I know some of the folks that we have are here from the energy sector, projects that we do larger than $500 million. Almost every single one of these projects that are happening around the world is behind the schedule. And the amount of delays that we're seeing with the cost overruns are quite significant. The numbers that you see on the screen are speaking the version of the truth. Now, ironically, if you wear your client owner hat and you start thinking about among various factors that matter to you, what are the most important factors? And if you only ask this question in the context of construction, this is the analysis you're going to see. So this is a report that was published by Dodge Data Analytics a few years ago. And last year I was at ENR doing another presentation, and we actually did a live survey with a little bit about 200 people. We roughly got the same number. Now, looking to these performance metrics, project design, safety, quality, budget, and schedule. Owners were being asked during the construction phase of their assets, what is the most important factor? The number one happens to be schedule. Let me say why. Everyone who's on the call here knows that front-end engineering, front-end design can actually save us a ton of money during construction. Of course, if you spend $1 extra in design, you can potentially save $7 of that construction rework that happens on your site. But of course, this question was not asked during the construction phase. Design was already approved by the owner in the context of what goes into our construction documents, what goes into our specification. Safety, we rely on our contractors to make sure safety is being managed and being planned for our job sites. Quality, that's what we have as specifications for us. And budget, that's why we have contracts. If there's one variable that is really difficult to manage, and there's a lot of risk associated to that, is a schedule. And that's because every day you delay a project, you're making an impact on owner client's ability to start generating revenue from the asset that's been built. Now, I really want to start working with you all on understanding what are the reasons that are causing the type of performance issues. And there are a range of reasons, but for the sake of today's conversation, I'm mostly going to focus on project controls, the way we plan, execute, monitor, and revise our plans on every job site. So if you think about that process, every project starts with a schedule. Then we communicate that schedule, whether that schedule is a master schedule or we've created a more refined version of that schedule. We go and execute those tasks on the job sites, and we get together on a timely fashion to understand what are the opportunities that we have for learning. We measure performance, and what are the opportunities that we have for improvement. And obviously, we want to use that basis to update our master schedule and go through that cycle. So whether you're following that sort of conventional earned value analysis or you're following a lean construction practice, you're always going through this cycle of measuring actual performance, contrasting that against the baseline, and finding the opportunities for improvement. There are 4 specific problems that our research shows that are associated with this cycle. Number one is how we are planning our projects. So over the past 2 decades, as an industry, we've significantly enhanced some of the capabilities that we have in planning. For example, lean construction is commonly accepted today on many of our job sites. But many observations that we've had recently shows that if you start getting into these more job site-driven planning practices, which are ideal for a job site. You're generating a ton of information. So we always need to have someone who would be associated with the project to coach the team on the process and make sure every piece of data that we have on the project is being communicated and coordinated. An example of that picture is shown on the right side of the screen here. Now, a lot of the job sites that we've been monitoring shows that you're always constantly relying on a champion on the job site to help you with the implementation of these lean construction practices. And the moment that we lose the opportunity of having these individuals engage in our project, there's always a chance that our folks would go back into retroactive practices, the practices that we always had. That we get together and we only look into things that have gone wrong, and we try to point our fingers at that party in that meeting that's responsible for the delay that's happened. Now, not only we are not good at coming up with a plan, when it comes to the execution, there are all kinds of things that can make an impact on how we come up with a plan. My focus is specifically on short-term plan, things that we create on a monthly basis, on every 3-6 week time frame basis, so we can make sure we understand what work every trade contractor, every subcontractor needs to be made. So I've been doing a survey for quite some time to capture what are the root causes for the fact that we can't execute these plans. And there are a variety of reasons. Work plans changes, natural to every project. Work areas are not available, we show up, and there's another contractor that's occupied that space. We underestimate productivity and all kinds of resource-related issues. If you look into these reasons closely, you would see roughly around 80% of them are preventable. The problem that we have is that insight, that visibility is not being offered to our project team members so they can actually see what is really happening on the site and have a basis for improving that. The third problem has to do with our practices for communicating and managing performance on the job site. Still many of our job sites are paper-based, and we see on a weekly basis, subcontractors are getting together with a general contract and meeting construction management company, and they're color coding 2D drawings to communicate how much work was done. There are other practices. Sometimes we send out our superintendents with a stack of drawings, color code how much work has been done, and of course, there's tremendous amount of technology that being introduced in this space, and we've digitized drawings, so we now color code these drawings in two-dimensional PDFs, perhaps. The problem that we have is the fact that from the time that something happens to the job site to the time that we learn it and the time that we use it to update the basis of schedule, we lose a significant amount of work. If you're involved in a data center project, that means every single day on your job site, there's roughly around $2 to $5 million that goes into your construction work. So a 5-day delay, that figure that you have for your weekly coordination meeting, is going to manifest itself in form of the delays that we have at the bottom line of the project. And the last problem has to do with unreported progress. Many of our construction companies around the world are still practicing planning in a more centralized fashion. So the folks that are actually getting access to the data to create the plans are not being provided with direct access to what is really happening on the job site on a timely fashion. So they can use that data and update the basis of plan. So we're always missing that feedback loop, that data that we can use to update the basis of the plan. Now, while I've been mapping out all these 4 specific problems in the context of that project controls, there's reason to be excited. There's hope. And that hope is, on one side, the opportunity that we see with adoption and adaption of BIM-driven workflows. Many folks that are on the call today, one way or another, you've used BIM, whether that's been part of your design development, that's been part of your constructability analysis, whether it's been part of your facility management handover, you're using BIM. So the concept here is to see if we can extend the life of these data-centric models that we have and tie them into other types of performance data, specifically schedule, and form a basis that we can communicate what work needs to be done every day on the job site. On the other hand, there's been a significant growth in all kinds of data. But like I said earlier today, I'm mostly going to focus on visual data for the sake of simplicity of today's presentation. There are all kinds of visual data. Sometimes you walk on job sites and take photos. We sometimes rely on professional photography to take photos for us. Time lapse is extremely popular around the world. 360 cameras. Nobody thought 360 cameras would be this dominant in construction, but with our involvement, we see hundreds of 360 videos that are being captured indoors and outdoors on many job sites. Drones. Construction is the #1 market for drones. And of course, laser scanning, a little bit more higher end, higher precision. So there are all kinds of visual data that are being captured, and they're simple to use because you show that to anyone who's affiliated with the project. They can understand how much work is being done, and you can use that as a base of coordination and communication. The problem is we need to figure out how they tie back into the design and transform insight and analytics off of them. So the opportunity that we've had is really come up with data-driven solutions. Solutions that can address some of these foundational problems that I mentioned about project controls by tapping into that type of data that we had. And of course, I already mentioned about it. So one example of that is the fact that you can come up with techniques on the AI side, for example, computer vision, that can take in all kinds of visual data that we have on the job site and transform them into measurable reality. That means now, not only are you looking at a 2D flat image, but you can click on pixels and you can measure length, you can measure volumes, you can measure areas, and track those changes over time. There are techniques that you can look into to bring your 3D design, 2D design into alignment against that reality automatically. So at any point in time, you can see what is there on site versus what should be there. And that's all tied to your project data. So you can use that as the basis of progress tracking. You can use that as the basis of quality control. You can use that as a basis of even safety monitoring. To get to this point, and I'll show you how, one of the strategies, one of the things that I've been working on, and there are quite a few other researchers around the world and startup companies too, is figuring out techniques that can automatically analyze contents of images and generate models of the reality on the job site. So this picture shows you that example. Whether you've used drones, whether you've used 360 cameras, there are techniques that could be used out there, including engines. I'll show you one live example in just a moment, that can process that data and give you a measurable model at any point in time visual data is being captured. And from the other end of it, you already have BIM tied to the schedule, so you can create the basis of comparing the plan against the reality. You can find ways, way that the data can be automatically registered against one another. So in a three-dimensional context, you see the color-coded BIM versus the reality of the site. You can find techniques that can automatically overlay that BIM for you on your site photos. And that site photo can be color-coded now based on who does what work in which location. So now your reality becomes that twin for your BIM in a sense that you have a layer of reality versus the design. And then you can tap into a little bit more advanced machine learning techniques that can contrast that reality against the design automatically and color code elements, tasks, work packages in terms of what is on the schedule and what is behind the schedule. And then you can even go one step beyond that. Learn these patterns of production and productivity you see on the site and use that as a basis of forecasting the future. So now next time you go into a coordination meeting, going back to those problems that I mentioned, instead of focusing over the past, we can all look into this visual. And we can see there's one location that's color-coded with orange. That location is at risk for potential delay, a delay that hasn't happened on the site. So we can use that insight, we can use that analytics to figure out what is the basis of improving our plan for the next cycle of the work. So when we go into the coordination meeting, we can use that visual as a base of our conversation. Everyone's going to be paying attention to what is at risk for delay. So no more being retroactive. It's all about being proactive here. Let's figure out what are the changes that we can make here together. What are the parties that are going to be impacted? And let's get buy-in from every party as affiliated with the project. So now we have a more reliable basis for performance of our project. And this is from one of our partners that actually used our Reconstruct platform in one of their coordination meetings. Now you've seen this type of work. This work that I performed and created the basis of Reconstruct was done in the context of academia. And over the past 10 years, the landscape of this type of work has dramatically changed. And there's been a lot of resources being offered in this space. We all know there's a lot of opportunity for innovation because now the data is there. The problems are being better explored and communicated. For example, the work that Projecting Success Group is performing. At the same time, there's a lot of investment that's coming to this space. But the path of how we can streamline that academic work, what really happens in the startup world, what happens in companies like Bentley, Autodesk, Nemetschek, and the like, is still unclear. If you want to put things into perspective, over the past 10 years, there's been a little bit more than $4 billion of money that's gone into startups. Back in the day, it used to be close to about 3 million, but now we see that value to be closer to $1 billion of money that's going to startup companies. Startup companies, of course, driven by immediate revenue generating opportunities. So they tend to focus on more low-hanging fruit opportunities. And that is one of those aspects that, there's a difference between how we see these problems from an academic perspective versus what startup are looking at. On the other side of it, there's a lot of opportunity. There's a lot of data is being captured, but that data is not being shared directly with these startup companies or academics. So it's always a constant battle to figure out how we can get that data. How do we address those liability aspects? Now, one great idea would have been if we could have tried a lot of these machine learning AI algorithms in the context of products. Every product has a workflow. So if our academics, if our startup companies are associated with these types of products, they can actually learn more about these workflows of how they get implemented on the job set. And that insight can be the basis of improving the AI solutions. The solutions by themselves, they can actually help educate the industry. Every single folk who's attending the call comes from one construction, design, client company. And we have, folks at various levels of background and work experience in our organizations. And what that means is that every organization is at a different grade in their journey toward maturity, toward AI-driven solutions. We can pick and choose how these solutions can help educate the industry and take one step at a time to go to the next level. Now, to address that, many of organizations, especially here in the US, have actually formed innovation teams over the past 3-4 years. And they're being constantly contacted by startup companies. And of course, they want to interact with academics too. So the question is, if you're part of that team, where should you really spend your energy? Should you just keep focusing on those startups that can give you that one small next step that you can take? Or should you be more focused on more foundational changes, or maybe a balance between the two? And of course, on the challenge that we see on our side, on the academic side, the demand for AI expertise is over the roof. Every single one of these students that are going to programs like ours are being very heavily recruited by software companies. So some of them tend to start working on products. So we are taking them away from the opportunity. And then obviously that difference that we have in academic work versus a startup, which is, we really want to focus on those big scientific problems, those foundational issues that I mentioned that are contributing to those delays and cost overruns, versus the bottom line, which is an immediate interest of startup companies. Now, if you think about it, this is what we do. So here I'm showing you a chart of going from idea to solutions on one axis, and on the other axis, you see basic research versus applied research. At universities, we tend to focus on things that are a little bit more basic, more toward the idea, because that's how we are being measured in our own success. Startup companies do have some overlap with what we do at university, but they tend to be a little bit more mature in terms of their technology readiness level. And of course, advanced technology companies have a lot of overlap with these startups. They have a lot of products and product teams that act like startups within those organizations, but they tend to be applied. So the idea was to see if we can put together a community that can streamline this entire cycle of going from ideas to solutions that can make an impact on the bottom line. So every party who's engaged in industry can be part of it. And hence the idea for an Institute of AI in Construction. We started tossing around this idea that, hey, we want to come up with an institute that can create those foundational ideas, help perform technology transfer, and train the next set of workforce on the technical side, that we can address all these issues that we all are passionate about: the safety problems, the productivity problems, the design, construction, and operation problems. So that really formed the basis of our institute, performing use-inspired and basic research on AI, looking to several aspects of education that can be offered to professionals in the industry, education that can prepare students to be recruited by innovation and R&D teams at construction companies or even software companies. And of course, that entrepreneurship. We don't want the ideas to stay at the academic level. We want to make sure that there's a vehicle that can easily translate that work into products that can be used today. And we want to make sure everyone who is affiliated with the process is engaged. So we started putting a team together, and I'm really excited to introduce my team members to you. We have a range of expertise within our team across University of Illinois and Carnegie Mellon, from David Forsyth to Julia Hokemeyer and Derek Cohen, all professors of computer science across the board on AI, computer vision, natural language processing, and machine learning. Birchu Akinci and Pimbo Tan from Carnegie Mellon, both are AI for construction. And the rest of my colleagues, Khaled, Nora, EJ, that do AI for construction, and Randy, who does AI for design and ethics and bias in AI-driven products. So with that team, we started reaching out to folks that we knew and response that we received from them have been overwhelmingly very positive. And today, we have a little bit over 180 participants that have participated in our first workshop to plan this institute. They want to make sure that is widely accepted by everyone who's part of the opportunity. Of course, we started here in the US, but immediately it attracted the attention of our international partners. So we do have a few international partners, but our presence has been dominant in the US because, of course, of the funding that we received here on our side. So we have members across the board, from construction companies, architecture engineering folks, from SOM to AECOM to Jacobs, owners, Microsoft, Amazon, Facebook as owners, tech providers from Autodesk, Oracle, startups. You can see quite a few of them on the screen here. Prefabrication companies, investment community, and of course, international partners, a few from Europe and some on the on North American part in Canada. So with that, we put together an institute, and we've been having a number of ongoing conversations as of now. What are the short-term projects that we want to be focusing on, and what are those more long-term opportunities we want to explore? How much of these types of work should be directly funded by the industry versus how much of this work should be funded by our national agency here on our side? What kinds of readiness are meaningful for construction companies to pilot technologies? Does it mean if I'm wearing my academic hat, I can easily pilot my solutions with the industry, or should I be more working with the startups and tech companies to do that? What are the aspects of sponsoring projects directly? There's a lot of competition in certain markets of the work, our work. We have to accommodate for that. IP, how do we accommodate an intellectual property model that works for every party is engaged? And data licensing, this is a slightly bold. Every company that we interact with, of course, rightfully so, they treat their data as gold. But data alone is not really everything. Data plus algorithm is all there is to creating that next level of work that we want to do. So we're coming up with a new model on how we can license data in a way that we can share and use that as a base of AI algorithms, and the derivatives of that can go back financially to those agencies and groups that are sharing that data. And of course, the educational aspects. So we've already had one planning workshop specifically on the construction phase. We have two more coming up. One is on the design side, and one is on operation and maintenance. We do have limited seats, so if anyone is interested, please do contact me. We'd be happy to link you to whether we can accommodate you, at least for the more public open sessions. There are a range of sessions that we perform. So there are 2 half days on August 5th and the 6th that we're going to be performing that institute. So with that, that sort of gives you hopefully a perspective of what we've been trying to achieve with our very first Institute of AI. There's one effort like this in Europe, and I had the opportunity of also presenting at the inaugural session for that. I'll be happy to answer any questions it might be on that. Now I'm going to go ahead and shift a little bit of my conversation. And I'm going to give you an example of why this institute is important and how do we get more AI-driven products formulated and delivered to the market if we can have that institute. And an example of that has been my engagement with Reconstruct. And it's really that basis of computer vision for construction management. So today, Reconstruct is that platform that commercially we reduce it as a visual command center. Now you know why it's visual, because it brings in your reality and design data together. The number one application for that has been progress monitoring, and by that I'm speaking really broad, progress and quality at the same time. We actually have quite a lot of use cases around inspection, to the degree that today Reconstruct is the basis of national guideline in the country of Japan for inspecting existing assets. So as of April of this year, there's a new guideline that was launched in the country of Japan. We've been working with the ministry for about 4 years now to formulate how we can maximize the opportunity on inspection through visual data. So now you've seen an example, what kind of visuals are possible to be generated through visual data. So the goal that we had at Reconstruct was to really figure out how we can automatically bring design and reality data into alignment, regardless of how visual data has been captured, whether that's been a drone picture, cell phone picture, indoors, outdoor, and it doesn't need to have any GPS tag to be associated to it, the content of the image by itself, and finding ways by which we can automatically contrast it to and color code locations, tasks, as to whether they're on schedule or behind the schedule. So as a platform today, this platform has integration with quite a few platforms. You can bring your data through any of those platforms, Aconex, Autodesk Paint 360 and Procore to give you a few examples. And what that means is that if you're hosting your visual data in those platforms, you can directly bring them in, or if you want, you can go ahead and directly upload that through a web interface. There's an engine, a computer vision engine that's been formulated that can automatically take in any type of visual data you have, whether that's a 360 video, whether that's a drone data, and can automatically generate a three-dimensional model of the site for you over project timeline. Think about Google Street View and think about that experience in a form that is measurable. So indoors and outdoors, you can walk on the site, measure angles, lengths, areas, and volumes from any type of visual data you have. To make sure that this process is complete, of course, we had to accommodate for laser scanning point cloud too. Alignment of that data over time is completely automated. No need for any ground control points, no need for surveying practices. They do enhance the process, but you can tap into the computer vision and have that data automatically aligned over project timeline. The deliverables on that front are 3D point clouds, 3D mesh models, and two-dimensional floor plans, as-built floor plans. And of course, that measurable street view experience is core to the entire deliverable on that front. So the number one use case for just that piece of the engine is visual documentation and creating a historical record for the project that you can use for coordinating and communicating any type of work. The next step is to bring design information. Because of the integrations that we have today, we can accommodate 62 different file formats of design. So if you're using BIM-driven workflows, Revit, Navisworks, IFC, that I know for all kinds of reasons is popular in the UK. If you're using Bentley products, Aviva Integraph, you can bring all that data and have that automatically register against reality. If you have a 2D-driven workflow, or if you want to have a hybrid of 2D, PDF, and 3D at the same time, you can also bring that. So at any position in time, you can visualize what is there on site versus what should be there. And the basis of that is extremely popular for quality assurance and quality control. The last piece has to do with production tracking, progress tracking. Long time ago, as a company, Reconstruct joined Oracle Accelerator program. We had the opportunity of being selected out of some 380 companies we were competing with. And we graduated from that program some time ago. But we ended up doing an integration, not only with Aconex and P6 as a choice of scheduling, but also Oracle Primavera Cloud and EPPM system. That means today Reconstruct can support importing master schedules, importing lean tasks, both into the platform, and create a hierarchical basis for tracking progress. Milestone that is more relevant to owners, and day-to-day tasks that are more relevant to subcontractors and contractors on the job site. And have that integrated against the design. So you can formulate a four-dimensional BIM at any position in time and have that mapped against the reality. Everything is managed through a web-based interface, so all users need to have is username and password. With unlimited number of users, this platform supports any type of interaction you want to have. For the folks that are out in the field, there are mobile apps that are complementary to this solution. The apps are automatically syncing against the web-based system. They also support offline mode, so if you have connectivity issues on the job site, you can download the data, have it on the phone, interact with it while you're on site, and when you come back to an area that you have connectivity, the data would sync back into the system. So with that, I want to give you a few examples of this platform, but instead of me taking you through a few slides, I'm going to give you a live demo. So let me see if I can change my screen. All right, now you should all be able to see a screen that shows you a corner of a building. Do you see that? Anyone can confirm that, that'd be great.
Yep, we can, yep.
Wonderful, thank you, Yoshi. So imagine today is Friday, November the 20th. What do you see at the bottom of the screen? Imagine you're wearing your client hat and you just received a payment application or you received an updated schedule and you didn't get a chance to walk on your site. You want to go ahead and see what's really happening on the site. So you log into the platform and immediately dial yourself into one view that you have available for you on that date, being Friday. I'm looking at the corner of the wall and I can see this payment application I just received happens to be around plumbing work. I'm looking at that plumbing work and let me see if I can assess the completeness. I see a few donuts on the ground. And I remember we asked the contractor to walk on the site with a 360 camera. So here the idea is that anyone on the site can mount a 360 camera on their hard hat. This is completely agnostic. It can be Insta, it can be Garmin, it can be Verb, or you can have it on the selfie stick. You walk around and videotape. The video automatically translates into this street view experience with these donuts. And if I click on the donuts, I can teleport you from position A against position B. If you notice on the lower left corner, I have a navigation map, and I can actually see what are those locations that we walked on the site to create this reality map. So not only you're looking at an image, I can actually pull my measurement tool and I can say, you know what, I'm interested to measure length. So I'm picking a pixel, I'm picking another pixel, and as you can see, I'm actually measuring length live for you as I'm interacting with the system. I'm going to go ahead and exit that measurement and clear my measurement as the basis of what I was showing you. So I'm going to go ahead and hover over the navigation map. You can see this person started walking from entrance, going around the site, coming out here. There seems to be a little bit of a trailer going on here. So maybe first let's go outside and see what's happening here. Now I'm teleporting ourselves into that location. I can see the surrounding of the job site. I can see the structure that I'm looking at. And I want to see if I can go inside the trailer. I'm going to go ahead and click on one of the donuts, and I'm going to go ahead and teleport ourselves into the trailer too. Here's the entrance to the trailer, and gosh, yes, that big monitor that I was expecting is actually being delivered to the job site. So with one video, everything is being mapped in 3D and 2D in a form that is measurable. Let's go back into the site. So let's go back to the corner. Now, I'm back into that payment application, also updated schedule workflow. The first thing I want to do is I want to check for quality. So I'm looking to this connection, and I remember as client on this job site, I was in that AECO meeting that we had a conversation around having a pressure drop somewhere in the pipe so we can make sure everything is sound from a design perspective. So what I'm going to do is I'm going to go ahead and activate my design and have that design sit here as an overlay. So now I can see reality against the design, and I can clearly see there's a delta between the two. So what I can do is I can toggle my pin tool, so I can create an issue right here in the field, or start creating a quick markup around the issue that I have here. And not only I can do the measurement between the design and reality, I can take a screenshot, and maybe I can even send that screenshot as a text message to someone who's on site. So now I have all kinds of basis for communication and communicating this issue. I'm going to go ahead and take you to a high level. I'm going to go ahead and hide my BIM. This is what the engine, that AI engine, has automatically produced for you. So from that simple video, the system has automatically generated a three-dimensional model. And that means I can actually create a location breakdown structure for my project. And I can actually show you the donuts that represent frames automatically extracted from the video. So for the person who's on site, all it means is capture video. Everything is happening automatically, but of course I'm explaining what really happens behind the scene in the system. So you have the 2D floor plan automatically generated and a cross-section version of that model. And you can play with it. So I'm going to go back to all location. I want to see if we can teleport ourselves and go back in time, because I also want to do an inspection for some of the mechanical components or equipment that have been recently installed on the roof. So I can see I have a few options. Every one of these orange dots you see on the timeline represents one day when reality was captured on the job site, some form of images and videos. So let's go back to November the 5th. Now, in this case, I can actually see a drone capture. And I'm seeing the entirety of the site with a point cloud and a 2D ortho photo that's been mapped against Google Maps automatically. And every one of these blue dots you see, like before, shows you one image or one frame extracted from that video. Not only I have the point cloud, but I can click on any location I desire, and I can teleport ourselves into the most relevant image of that location. So let's go to an image. Now we're looking at the image by itself is measurable, and I can say, you know what, show me the design as an overlay. So if you're concerned about your underground utilities from a design perspective, and you want to see what that looks like against the structure, you can have that automatically aligned. So I'm going to go back to the high level, so you can actually see the design model, and I'm going to go ahead and activate the reality against it. So everything that I've shown you has been on the 3D side of the process. This also comes with a completely dependent two-dimensional view that I can go into. And what that means is that now you're going to be able to see Google Maps. You will be able to see an ortho photo that's been automatically overlaid on top of it. And in the moment, you're going to see a two-dimensional drawing, a simple PDF that is also being brought into alignment. The alignment between the 2D PDF against this reality is completely automated. There's another range of AI algorithms that find edges, corners, walls, and it tries to use that as a base of auto alignment. And there are all kinds of interactive tools in this system that you can use to update the basis of aligning your reality against the design. So now I'm showing you a few kind of examples of capabilities of this platform. Let me head back to my slide here and see if I can kind of take you to a few things here. So One capability I showed you has been really about that visual documentation. And what it means is that you can generate a historical record for the project, document any assets, do measurement, communication, and coordination by itself. And it's as simple as just recording a video. And of course, when it comes to managing risk with the pandemic that we had, this became extremely popular, not only with our platform, but many other vendors that are active in this market. Now that you've seen the capability around visual documentation, I want to speak to a little bit of the quality of overlaying the design. Of course, when you start thinking about 360 photos and reality capture solutions, they're great. They show you what's really happening. When then you map the reality of the job site, so you take the next step of reality capture, and you do your design as an overlay, you have all kinds of opportunity for quality control. So this is actually a project in Europe, in actually the tallest building that's currently under construction in Europe that's in our platform. And what you can see is an MEP coordinated model that's been overlaid on top of the 360 photo. So you can use this for verifying construction openings, making sure your production plan is sound for any type of installation or placement that you perform on the job site. Here's another example here in the US. A significant amount of work was done actually on coordinating BIM for this project. This is a healthcare facility. And the example that I'm showing you is an overlay of the coordinated MEP model overlaid on a frame extracted from a 360 video. What do we see here? We can actually see during the design MEP coordination, there was a coordination done around putting the HVAC system to go around our fire protection system. But unfortunately, the trade contractors ended up installing it as one piece. Before this is signed off, before we have the next trade, we can catch it. We can catch it and start seeing if we can immediately address it before this becomes a liability issue associated with the project. If you're doing placement of concrete, which is very popular with self-performing contractors, you can have your cell phone photos or drone photos automatically create a map, a three-dimensional map of placement of your concrete components, and then you can do the design overlay. Whether that's a 2D design or 3D, you can do that. And in this case, you're actually seeing 3 sleeves openings that are overlaid against the design. I've actually placed 2 pins on the picture for you, so you can see an immediate deviation between the reality against the design. This is actually from a real project that I recently presented with a customer of us. So the example that you can see here can be immediately used as a basis of addressing these sleeves. So what does this mean in terms of value? That means you can actually go ahead and minimize rework that typically happens on job sites. For that example that I showed you, for those sleeves in one capture, that can mean $6,000 of saving. It's a small value, but if you had interest in seeing more stuff, there are case studies you can download. For example, we worked with a car manufacturing company in Michigan, and on that project, we were able to demonstrate $1 million claim was actually being resolved because of this transparency that the system can offer you. So what does it mean to the folks that actually perform quality control? Speaking about the ROI and some of the questions that we all responded to in the survey earlier today, we also had to measure that. So in the old-fashioned way of performing field verification on MEP rough-ins, this specific team that we work with in Virginia, they used to spend about 2 half-a-day visits per month plus the reporting. You'll be able to bring that to a number of hours. So roughly it was almost a day per month of full-time employee saving, and you have a higher quality basis for your quality control, and you have on-demand access. You can access the system at any point in time and address that workflow. Fast communication issues, and of course, this is that system of record for the project, right? So you can use that as a basis of creating your monthly progress updates and model deliverables that I know they're very popular in the UK. So the last component has to do with integration against schedule. In this system, as I mentioned, you can bring in Microsoft Project, you can bring in P6, you can bring in Asta Power, and you can tie that against the design or just have that mapped against the reality. So if you tie that against the design on that blue timeline slider, you can form the basis of the plan, and you can have that as an overlay against the reality. With no automation, you can immediately verify how much work was done and what is left to be done. You can understand who does what work in which location, perform a quantity takeoff, and use that as a basis of your reporting. And of course, when you tap into reporting capabilities, not only can color code your models based on what is on schedule, what is behind, you can look into that predictive aspect of this engine that I mentioned earlier, forecast the future as a function of past performance, so we can proactively start addressing this. The example that I'm showing you is on a $1 billion project in state of Florida. This is a convention center with a hotel that are under construction today. So this is actually a live project in the snapshot I'm showing you. Here's another example. This is a project in California. This one is actually close to about $2 billion with an owner. And in this case, the use case was really payment application beyond just progress tracking and coordination. The idea was this team was out of Seattle. The project was in California. They wanted to make sure they can expedite payment application, which matters to all of us when we are wearing our construction hats. So in this case, you can actually see the work is being documented and used as a base of payment, indoors and outdoors, with a combination of 360 videos and of course, drone data. All of this can actually transport itself into dashboards that I'm not going to show right now, but you can see that in Power BI, you can see that through BIM 360 integration, and now it means we can change these practices. I'm showing you a recorded video of a coordination meeting, and the superintendent running the meeting using these visuals. There are reports generated, printed out from the system with that larger screen that shows locations that are highlighted. So now our conversation is, what is that location that's at risk? Who's being impacted? Now you see the gentleman on the right side of the screen is standing up, engaging in that conversation. His team and his subcontracting company is being impacted by this issue as much as the project is being impacted. So now you have a basis of making an impact on the bottom line. So over 6 weeks of work, this team was able to change their percent plan complete on their lookout plans from 46% to 70%. And I'm sure everyone on the call here agrees with me. This is no magic. If you offer data that shows you what the problems are, and if the team is willing to take an action against it, of course you can improve the basis of the plan. You can have a more reliable plan as the basis of the work. So all I wanted to point out is to kind of show you a few examples of how you can leverage types of AI algorithms that are commonly available today through startups, technology companies, as a basis of creating value. In the context of visual data, that means transparency. Transparency that gives you that ROI. At a very high level, if you want to have something really, really tangible, that means those visits that we make on the job site, right off the bat, can be minimized. There are a few case studies that can tap into how much travel time has been minimized for going to job sites and just performing those visual walkthroughs that we all perform on job sites. When it comes to quality control, I showed you one small example with concrete placement. Here I'm pointing out to that example that I was mentioning about a car manufacturing plant with a saving associated with a persona who does it. On the scheduled delivery, there are many examples. I showed you a video with a superintendent running a meeting. Not only it impacts the bottom line, but it also impacts the person who has to chase down the subs to get that information to update the basis of the plan. And of course, for clients, this is really that digital handover. They hand over at the end of the project that it has the version of the truth and the design in one integrated environment. So this is really that strategy that we can tap into the data to create a win-win environment for every party that's engaged in the project. So that's all I had to share with you today. Kind of give you a little bit of glimpse of what's happening at the institute level, and I kind of give you a live demo and a few slides to kind of show you capabilities of Reconstruct as an example of something that can come out of the institute. That's all I had to present, and I'm open to any questions you may have for me.
Excellent. Thanks, Manny, for that. We have got a few questions for you. I'll just read those out for you and you can respond accordingly.
Sure.
So we've got a question from Martin here, and it says, what do you see as the key 3 challenges that the Institute is currently grappling with?
It's a really good question. So let me see if I can head back to one of the earliest slides that I was showing in the context of ongoing conversations that we have. And I have to wear several different hats to respond to your question. So you said 3, and I'll pick one of each type. If I wear my academic hat, one of the challenges that I see is the way we've been incentivizing academics to work on AI-driven products in the context of construction. Academics are performance of any professor, any student is being measured by contribution to the body of knowledge in terms of how many articles are published, how many presentations that are made. It's fundamentally different from how many times you had success or even failure with transferring your technology to something that can work. So that model needs to change. There's a lot of improvement on this side of the pond in the way we measure performance of our faculty members and students. And I think that's a piece that we hope that we can bring more clarity through the Institute. The second has to do with IP. A lot of universities are always trying to protect the intellectual property to the degree that would help them generate revenue from it. And the spirit is great, but there's a lot of risk associated with tech transfer. if you wear your startup hat, if you wear your business hat, it's not about the technology only. Technology would be 10, 15, at most 20%. 80% of it has to do with that business model. So there's a lot of risk for that. If you want to engage that investment community in a more proactive manner, we need to come up with very simple IP formulas that the risk associated with the tech transfer is known to every party and form the basis of improvement. And the last one, the third one, is really that data. Data is core to everything we perform. Algorithms are key to leveraging that insight, but finding a formula that companies and industry are willing to share the data in a form that matters from an AI perspective is key. We have a few ideas, and I'd be happy to discuss them with you offline in terms of how we can help companies monetize on sharing of their data to institutes. So these will be the three top issues.
Excellent. Another question here that we have is Oracle participating as a client of construction or as an IT provider?
That's an excellent question. Both. We have partnership with them as Oracle Facilities, which is that division that operates and maintains their facilities and manages construction and design. And of course, Oracle as a provider. A lot of it really started from my startup company being engaged, and Oracle has actually taken a front seat in helping us provide some of the resources that we need on the IT side, as much as it's helping us with getting access to data and things of that nature. So Oracle is actually engaged on all fronts. The same applies to Nemetschek, Autodesk, and Bentley. So we don't want to, leave anyone out. Everyone is welcome to be part of this institute. This is plain field, an opportunity to streamline processes. Of course, we all compete with each other on the commercial end, but then at the end of the day, we want to make an impact on those problems that I mentioned earlier.
Excellent.
And a great partner.
Another question as well. Are you collaborating with other project organizations outside of construction?
If there are some examples of what kinds of organizations you have in mind, that would be helpful. If you're asking about the institute, let me see if I can put back some of the logos that I have here on my slide, so you can kind of see what kinds of organizations have been engaged. We have not been publicly presenting on this idea of institute a lot. So a lot of these companies you see have been our own personal connections and interactions that we've had through our own practices that we brought people on board. So you can see the range of organizations: architecture, engineering firms, on commercial buildings, industrial buildings, heavy civil, energy, oil and gas owners, primarily tech owners, but we do have government agencies engaged here too. One example of that, a little bit more local, is New York Department of Design and Construction, who's part of our institute. I've already mentioned about tech providers and startups. Investment, specifically those investment firms that invest in AEC, and our international partners. So other tech providers, for example, we have Boston Dynamics has been a partner on the hardware side, and a few tool providers, including Hilti and Bosch. Other questions?
Another question. Yep. Another question for you, Manny. Looking 5 years into the future, how will project delivery be different?
Oh, that's an excellent question. I wish I was able to give it a straightforward answer. I was excited when I saw Yoshi presented the next presentation on IPD. When you think about improvements, there are three components to it, right? Product-driven improvements that can be made, process-driven improvements that can be made, and organizational changes. There's a lot of improvements that needs to be made on the process and how organizations adapt to those changes, so we can enhance our project deliveries. And many times those are more impactful compared to bringing products or even AI-driven solutions as part of that. Those are key. There's a lot of conversation that's happening through quite a few agencies. At least I can speak on the US side. IPD has become really common with healthcare facilities on the West Coast, not everywhere in the US yet, and that's gaining a lot of popularity. And that's changing the way we are delivering projects. Design build over the years have become extremely more popular compared to design builds. And the way we are also creating contract types have have improved over the years. I don't, feel I'm in a position to comment on how this is going to change. My hope is that we can look into more of these collaborative forms of project delivery, like that example of IPD, so we can de-risk the process and bring that transparency. It's more of a cultural change as opposed to even a process change. So a lot of work is being done in educating what the client and owners can do. My thought on that front is having owners and clients sitting to these types of presentations is key to making that change. I think I'm going to go more toward those collaborative models in the next 5 years.
Cool. Another question here from Alex. How will this AI approach help improve automated generation of corrective actions and recommendations during design and construction?
That's a wonderful question. So I'll share with you a story on that front. Of course, with Reconstruct tool, you saw that that tool can automatically color code what is, for some types of projects, what is on the schedule, what is behind. It doesn't always do it automatic. There's always some element of manual input to it too, or even the forecasting piece. You may be surprised that there are times that project teams are getting engaged and they see those locations that are at risk for potential delay, and start thinking about what are the remedies that we have on the project controls, right? Immediate thinking is that let's put more people on it. The better approach would be, let's figure out if there are underutilized resources, maybe locations, tasks that we can assign to other people, or from our backlog, so we can have more productive work happening across multiple locations. So there are, of course, these ideas. And the question has been always asked is, can we prescribe these changes? So at the University of Illinois, I've actually led a research project which taps into schedule data and comes up with recommendations for change. These recommendations are not based on optimization techniques. They're purely driven by understanding of best practices extracted through natural language processing and using that as a basis of making recommendation. So you might have been familiar with some automated techniques like great startups like Alice. Even in the UK, there are organizations like Nplan that are working on problems like this. The idea that we had was to learn these best practices automatically from a schedule data. And when it comes to these deviations that we see, maybe we can pull some of those best practices that can be brought into a case-based reasoning. For this issue that you're facing, from what we've seen from historical data on your project, this is likely going to be that best practice. So we have a little bit of R&D on that front. There are a few articles that are published on that front, but none of it is ready to be used in the industry today. So I'd love to see if we can move toward prescriptive data analytics as opposed to just predicting.
Excellent. Just a few more questions.
Sure.
How accurate is the measurement from the model generated from field photos?
Oh, that's an excellent question. It really varies. It varies based on what kind of camera you've used, at what distance you've done the capture. You can do all kinds of resolutions that matter to you. If you use, I'll just give you a few examples. If you do a standard drone capture, which roughly happens around, in metric unit would be around 30, 50 meters away from the ground with an average DJI drone, you can rest assured that your resolution will be roughly around, at best, 0.5 centimeter per pixel or 1 centimeter per pixel. Now, if you tap into image-based measurement capabilities, and there's a blog post that we posted on Reconstruct website, you can look into it. There are strategies that can be brought in to enhance the capability of measurement. Then you can get into bringing that into even 1/10 of that resolution. Now, if you want to get into inspections, the requirements for inspections will be closer to, let's say, bridge inspection and cracks, 0.2 millimeter. Then if you leverage other types of cameras, for example, 40 megapixel camera, and you keep your camera very close to the structure, you can actually get your resolution down to millimeter. But for an average 360 video capture, for an average drone capture, it's roughly around 1 centimeter per pixel, roughly. And again, you can always enhance it if you put more effort in following the guidelines that are being offered for better capture. So think about it with the following strategy. There's going to be daily captures we perform, and these daily captures can help us kind of identify potential problematic areas, and we can check openings, conduits, spacings, and embedments. For that, probably 1 centimeter per pixel does most of our needs, right? It supports many of the quality control workflow. It's not flatness and plumpness measurement that we do every single day on every job. So that does that workflow. And for those moments that you really need that high precision, you can follow the guideline in different ways by which you can guarantee that desired resolution that you want to have available to you. Of course, If you can tap into robotic platforms, you can get that accuracy. Or if you have budget for laser scanning, I would always say for most precise measurements you want to perform, always resort back to laser scanning. And the beauty here with this platform is that it caters to all those data. You can mix and match it. Every day, have that video-based 1 centimeter per pixel capture that you can sort of rely on. And when you need, prior to placement of concrete, when you need that plumbness assessment, resort back to laser scanning so you can get that high precision.
Excellent. Another question here. How can AI be used in quantitative risk analysis, replacing Monte Carlo simulation tools?
How AI can be used for Monte Carlo simulation. So yes, I don't exactly know what you're asking, whether AI can change that process or you want more of a generic response. So let me see if I can give you a few examples. And I'll be happy to share with you those articles. Like I said, one of the challenges with any type of conventional statistical models for prediction has been the need for a lot of data that is within a range. So most optimistic scenario, most pessimistic scenario that we can have, and doing sort of a sensitivity analysis to some of the variables that would make an impact on the bottom line. So we had to handpick what kind of features for these methods should be used so we can relate the outcome to the issue in the first place. With a more modern machine learning, with the more modern AI algorithms, we don't want to dictate what features should be used. We want to pass the entire data and see if we can automatically map data to layers in our deep learning algorithm to that outcome. So one of the things that we've done in our predictive analytics is to purely pass production rates and productivity rates. The numbers of production rates that you get daily, weekly into an engine, and we want the engine to automatically learn those patterns of data. We have subcontractors that start their work early in the week, they ramp up halfway through, then they slow down to the end of the week, or even at the task level. We have companies that start slow and they ramp up toward the end of their activity. We don't want to dictate what days in a project delays are happening, what kind of root causes contribute to the delay. We want the data to automatically we want the algorithm to automatically learn these patterns in the data. So there's a range of deep learning algorithms, and I have published some of them. There are a few other academic folks in the UK that also work in same areas. You can tap into these techniques. The fundamental philosophy on how these algorithms are being created is different from the old-fashioned way of thinking about risk, which is still very, very powerful. So that's sort of, hopefully this gives you an answer. We're more thinking about techniques that can learn these patterns automatically without hand-picking or hand-designing features anymore.
Excellent. I'll just ask maybe 3 more questions to wrap up for 8 o'clock. A question here, do you need to build a separate schedule as many clients use extremely detailed schedules?
It's an excellent question. Yes and no. I don't exactly know in what context of this presentation you're asking that question. So let me start with a yes. Let's think about that predictive color coding that I was showing, that there are locations that are being color coded. Now, let's pick contractor A. Contractor A has 200 projects. I bet you agree with me that that company across the board, across projects, they have different project teams and the performance even varies. So if I use historical data from that company, it may not immediately translate to that project. So the thinking there was to train these models with project-specific data so we can use that as a base of improvement. And when I say that, that can mean that detailed lean task level schedule, or if you have a desire to do this at the master schedule, get this prediction done at that level. So there's enough flexibility on the engine side. Whatever you feed into it, it can use that as the base of prediction. It comes with pros and cons in terms of precision and recall of the method, but it does work. On the other hand of it, historical data can be really helpful from a high-level master planning perspective. But here there's enough flexibility to accommodate the two. But the biggest challenge is the following. When you have master schedule and then you have detailed schedule, and you want to figure out if you can tap into both for learning machine learning models. That's the biggest challenge, because there's always a disconnection between that granularity of the data between master schedule and lean. That even applies to natural language processing. The way we write in English, the description of our task varies between that detailed schedule versus master schedule. There's another work that I've done on automated alignment of these schedules. If you had an interest on that front, I'd be happy to share that with you. That shows you how you can automatically link your detail schedules against master schedules. And once you have that, you can use the hybrid of the two for forecasting. Like I said, that's more of an academic work that is not ready to be used, but that's definitely one of the early works on that front.
Cool. And just two more questions. Have you looked at shipbuilding?
It's an excellent question. There's actually a lot of similarity between shipbuilding and the way we've been approaching scanning and model-driven processes in construction. I don't come from that background, but over my life in this business, I've interfaced with folks that come from that background. So I've learned a few things in terms of reality mapping, the value of automatically creating these models as the base of any type of improvements that we make. So some of these capabilities that I showed in terms of reality mapping, for example, taking the 360 video feed and automatically generating floor plans, automatically generating 3D models, and that measurable street view definitely immediately translates into shipbuilding. If you have model-driven practices on that front, integration of that against the reality so you can see what is there versus what should be there is also relevant. Now, I don't know exactly what sort of role you play in that world, but I'd love to learn a bit more, and I can show you how potentially some of these techniques may translate immediately into their practices.
Cool. And I'll just go with one last question. Sorry, Ken, because I know you've asked some excellent questions here, but I'll go with what James has put. There are many different software solutions and vendors out there at the moment, all positioning themselves for the wave of change coming. Do you think a few frontrunners will emerge to become industry standard, or is there space for everyone?
It's a really tough question for a number of fronts. From one side, I always appreciate standardization. From the other side, I'm always concerned because there's not necessarily one solution that fits all problems that we all face, right? Just pick an example on the reality capture, right? We do all kinds of captures. Laser scanning is always going to continue on being a laser scanning practice because it's very accurate. It comes at a price, but it does fit certain purposes. And then we have the 360 video-based workflows. There's going to be some consolidation that's going to happen in the industry because there are some point solutions that compete with one another. So among point solutions, yes, I definitely see a lot of consolidation is going to happen. And unfortunately, the reality of how investment works and how investment community values the work of startups, we're going to have a few people that, unfortunately will leave the industry. So eventually you're going to see a few front runners that would emerge. When there's a lot of competition, my personal feeling is those products that are more integrated in the product in terms of workflows, and those products that are a little bit more visionary are the ones that are going to be standing out. The crowd of all these startups are all going to contribute with educating the industry of what is possible. But once you get started, you're always looking for that most advanced solution that you can bring into your organization toward that point of you made about the standardization. So I think when you see a lot of consolidation across startups and you are thinking about, what are the low-hanging fruit opportunities, maybe you want to come with a strategy that looks into a short-term impact and long-term impact. There are things that you can immediately start using today. Whichever software is more user-friendly is likely going to win that. But as you're thinking about a more long-term strategy on standardization, you want to tap into those more front-leading solutions that can scale with you for long-term. So we are going to see some consolidation across these point solutions, but that competition is actually good. Having a little bit of that right now is actually helping the industry push the boundaries of these solutions forward. The downside is that, unfortunately, I have to use this word, there's a lot of pollution with the word AI and machine learning. So it's harder to differentiate what is real and what is not. So one of the goals that we have at the Institute is when we perform presentations like even the one that is happening here, hopefully some of that can be clarified a little bit more deeper in terms of what is real with AI and what is not. When you hear that some companies generating automated progress report, does it mean they have people behind the curtain that are color coding the model for you, or is that really automated? So institutes like the one that we're initiating, hopefully can bring you a little bit more clarity on your choices on what solutions you can use today and what solutions you will want to use tomorrow.
One more question, or do you want to wrap it up here?
Yes, I'd be happy to answer one more question.
Yeah, one more question. I think we'll go with the one here who hasn't asked a question before. Do you plan integration with AR and VR technologies?
That's an excellent question. Yes, we do have integration that we've piloted. For example, we have integration with HoloLens for that solution I showed you. I see a lot of value in that, but at the same time, you always have to keep in mind when it comes to AR, hardware is a key point, and a lot of these AR headsets are still in more of an R&D mode. Of course, HoloLens is one of the very few that is very mature and can be used, but it still does come with a number of limitations. My biggest concern, and someone who's actually spent part of my life on AR technology, I'm always concerned about the safety. As much as I've been working on products around AR, specifically AR, not VR, I'm always concerned that we have all kinds of safety hazards on the job site. If you're augmenting someone's view with more information, there's always that danger that that extra layer of information that is deemed helpful to them may constitute another safety hazard by itself. So I'm really passionate about finding a way that we can bring visual data through AI or VR platforms in a way that it doesn't jeopardize safety. I think that's one of those topics that deserves more research. But if you're purely asking from a product integration, absolutely yes, there are things that can be done today, and I'll be happy to show you examples if that's something you want to try. But just wanted to point out the issue that I personally see with safety, broadly speaking.
Excellent. Well, thank you, Manny, for that. I think that was an excellent presentation. We've got a lot of great positive feedback. For the guys who didn't get their answers, their questions answered, particularly Ken, we can forward that to Manny post-event, and hopefully Manny can get back to you.
I provided my email address down here. If you had interest in taking 2Ds and generating 3D models, scanning in 2D and producing a 3D model, contact me. I'd be more than happy to give you examples of how that can be done. Thanks for the opportunity, and thank you for your attention and questions.